This is mathheals.com, where you can go to get more links to math YouTube videos and computer science. Let's take a look at compound inequalities. And our first problem, we have A is equal to 2, 3, 4, 5, and 6. And I'm not going to write B down because this problem doesn't use B, it just uses C also. So let me write down C. C is 2, 4, 6, 8. And we got this right here. This is referred to as the union. And what you do with the union is merge the two sets together. So merge the two sets together. Arrange from smallest to largest. And don't repeat any. So no duplicates. So don't repeat any. Okay. Well, this one's 2 through 6, so I know that's going to be there. 2, 3, 4, 5, and 6. Well, 2 we already wrote down. We don't want duplicates. So, and 4 we already wrote down. Don't want that. 6 we already wrote down. 8 though. That's a new one. So that would be our union of A and C. Now in number 2, we want write that down. A, and then this weird looking symbol, C. This is the intersection. And when we're talking about sets, then we only want what they have in common. So only want what they have in common. So if I look at A and C, well, they both have a 2, don't they? So they have that in common. They both have a 4. They have that in common. They both have a 6. So they have that in common. Now the 8, only the C has it. And over here, the 3, only the A has it. And the 5, only the A has it. So our intersection is 2, 4, 6. Now it changes when we get to graphs. So let's take a look at that. We got A is equal to the set of all x values such that x is greater than or equal to 3. And B is the set of all x values such that x is less than 1. And I think this is the same one we have for number 3 and number 4. Yes, it is. No, I'm lying to you. They're different. Oh, I see. Parts A and B here. Well, let's graph this first. Here's 1, 2, 3. Now, here we got x is greater than or equal to 3. Well, greater than or equal to. The equal to part means you put a bracket on it. And greater than means I shade to the right. Which is that right there. Now this one is x is less than 1. Less than, and there's no equal to part on it, means this is parentheses. And less than means I shade to the left. So it looks like that. Now A says A intersect B. Now for the intersection, this is where they are both shaded. What they have in common. Well, if I look at this, they don't have anything in common. So this would be the empty set. And then part B is part union. Yeah, union. This is where anything is shaded. So this is where anything is shaded. Well, this is shaded from 1 to the left, so it's going to negative infinity and 1. Now, parentheses on 1, parentheses on 1. Infinities always have parentheses. Now this is from 3 to positive infinity. And parentheses on infinity. Bracket on the 3, bracket on the 3. And then we put a union symbol in between them. And that'd be our answer. Let me start a new page. And we'll look at the next one. We've got E is a set of all x values such that x is less than or equal to 3. And F is a set of all x values such that x is greater than or equal to negative 1. Well, let's graph these first. We want to graph them. I always want to graph them on the same number line. Well, negative 1 is here, and 3 is over here somewhere. Well, let's start with this one. X is greater than or equal to negative 1. Equal to part on that makes it a bracket. Greater than means that shade to the right. Which looks like that. Another one is x is less than or equal to 3. The equal to part means there's a bracket on here. And less than means I shade this way. Okay. Part A. Find the intersection. Of course, it's not A and B. It's E and F, but same difference. Okay. E and F. Well, remember what I said about the intersection. The intersection is where they're both shaded. What they have in common. Well, they're both shaded between negative 1 and 3. So this would be negative 1, 3. Now bracket on the 3, bracket on 3. Bracket on negative 1, bracket on negative 1. And that'd be your answer. Now B is a union. Now the union is where anything is shaded. Well, it's shaded everywhere. So where anything is shaded is from negative infinity to positive infinity. Now where this comes in, why they're even covering it in the first part of this section, is sometimes when you're solving a problem, you solve it down, you got all of your steps right, you look in the back of the book, and it's just like, whoa, where in the world did they come up with this weird answer? Sometimes you don't understand where they get the weird answer unless you actually graph it, and then it becomes real obvious why they get the answer they do. And that'll make more sense as we actually look at problems. Well, let's look at a compound inequality. So let's look at number 5. And we got x minus 5 is less than or equal to 2, and 3x minus 2 is greater than or equal to negative 8. Let me scratch my eye. I was out there mowing and it got a lot of dirt in it. Okay. Well, we got two separate inequalities here, connected by an and, or it could be connected by an or. What you do is you go ahead and handle each of them separately. Well, if you remember our steps for solving a linear inequality, first step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x on one side, numbers on the other. So I'll take negative 5 over. When you take anything across your inequality symbol, the sign changes, so the negative 5 becomes a positive 5. At any step, combine together numbers. 2 plus 5 is 7. Okay, we'll do the same thing over here. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on one side, numbers on the other. So I'll take negative 2 over. Take anything across your inequality, the sign changes, so it becomes a positive 2. Combine together the numbers in any step. Negative 8 plus 2 is negative 6. And the last step is divide both sides by the number in front of your x, which is a 3. And we get x is greater than or equal to negative 2. Okay, now the and, what that represents is our intersection. So let's graph these so we can see what our answer is going to be. Here's negative 2, and here's 7. Okay, x is greater than or equal to negative 2. Well, the equal to part means a bracket, and greater than means I shade to the right. Like that right there. Now the x is less than or equal to 7. The equal to part means bracket, and less than means I shade to the left. Like that. Now remember what our intersection means. Intersection means it's where they're both shaded, which is between negative 2 and 7. And bracket on negative 2, bracket on 7, bracket on negative 2, bracket on 7. And that's our answer. Now sometimes, in order to really understand where in the world they get that from, you have to look at your graph, just like this one. Graph solution set, well, I guess we could graph this, but that's good enough for what I'm looking for. And starting page. Now this next one's a little bit different, and I'll write the steps down, then we'll actually solve it. It's got 3 sides to it. So let's take a look at how to solve something that has 3 sides. Solving a 3-sided compound inequality. Our first step is to get rid of parentheses. Our second step is to get rid of fractions. Now we get rid of parentheses via the distributive property, and we get rid of fractions by multiplying everything by the LCM of all our denominators. Step 3, and I'll write this in terms of x's, but you can have any variable. Get everything with an x in the middle. Numbers on the other 2 sides. Because we've got 3 sides we've got to worry about now. Step 4. Divide all 3 sides by the number in front of the x. And we have a note goes along with this. If you multiply or divide all 3 sides by a negative number, flip the inequality symbol. Actually, you'll have more than one inequality symbol, so I'll say flip the inequality symbols. Now our answer form, how we want to write our answer, how we have to write our answer, I should say, is going to be, and I'll put a number here so you can clearly see it. It's going to be of this form. Your smaller number always has to be on the left side. Your larger number always has to be on the right side. The symbols that go in here have to be lessons or less than or equal to's. So that's the way we have to write our answer. And we have to do a little bit of manipulation in some problems to get it in that form. Let's take a look at this problem. We've got negative 10 is less than 5x plus 5 is less than or equal to 3. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x in the middle, numbers on the other two sides. So I'm going to take this 5 and move it to the right side and move it to the left side. Just like before, when you take anything across your inequality, the sign changes. So this becomes negative 10 minus 5 is less than 5x. Is less than or equal to 3 minus 5. Negative 10, negative 5 is negative 15. 3 minus 5 gives us negative 2. Last step, divide all three sides by the number in front of the x. The number in front of our x is a 5. So I'll divide all three sides by 5. Negative 15 divided by 5 is negative 3. Those 5's cancel, gives us x. And this gives us negative 2/5. Now negative 3 is our smaller number. This is our larger number. And these are less thans or less than or equal to's. So we're fine there. It says graph your solution set. Well, less than here means parentheses on the negative 3. Less than or equal to means bracket on the negative 2/5. The line underneath is what tells you bracket. And then we're shading in between. Like that. But that's our answer right there. Let's look at another one. Zero is less than 5/3 x. Minus 2 is less than or equal to 4. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. I only have one denominator, the 3, so that's our LCM. So multiply everything by 3. Now when I say everything, I'm talking about what's separated by pluses, minuses, and inequality symbols. So multiply 0 times 3, the 5/3 x by 3, the negative 2 by 3, and the 4 by 3. Well, 3 times 0 is 0. Over here, these 3's cancel. And we got 5x. 3 times negative 2 is negative 6. And 3 times 4 is 12. Third step, get everything with an x in the middle, numbers on the other two sides. So I'll take negative 6 to the right side and to the left side. Take anything across your inequality symbol, the sign changes. So we got 0 plus 6 is less than 5x. It's less than or equal to 12 plus 6. 0 plus 6 is 6, 5x. 12 plus 6 is 18. Last step, divide both sides by, or divide all three sides by a number in front of your x, which is 5. So we've got 6 divided by 5, 5 divided by 5 with an x, and 18 divided by 5. So that gives us 6/5, and those 5's cancel, and gives us 18/5. Now to graph this, less than on the 6/5, so parentheses on the 6/5. Less than or equal to on 18/5, so bracket on the 18/5. And shade in between them, and that's our answer. Let me grab a drink here real quick, and then we'll do the next problem. negative 4 is less than negative 7 times x minus 1 is less than 10. First step, get rid of parentheses. Well, we use the derivative property. You take negative 7 times x, negative 7 times negative 1. Negative 7 times x is negative 7x. Negative 7 times negative 1 is a positive 7. Now notice I didn't flip the inequality symbols. Our note says when you multiply or divide all three sides by a negative number. That's if we decide to multiply everything by negative 2, for example. Okay, second step, get rid of fractions. Don't have any. Third step, get everything with a x in the middle, numbers on the other two sides. So I'll take 7 to the right side and to the left side. Again, when you take anything across the inequality, the sign changes, so the 7 becomes a negative 7. Combine together numbers at any step. Negative 4, negative 7 is negative 11. Negative 7x. And 10 minus 7 is 3. Now last step, divide all three sides by the number in front of your x, which is a negative 7. So we're going to divide all three sides by negative 7. Now we're dividing all three sides by a negative number, so we flip our inequality symbols. They go from a less than to a greater than. Well, negative divided by negative is positive, so we got 11 sevenths. It's greater than x is greater than negative 3 sevenths. This isn't in the right form. We want our smaller number over on the left side. Well, let me move it over there. And a larger number on the right side. So move it over there. Then x in the middle. When I rearrange it like that, we have to keep our relationship true on the inequality symbols. See here how the small end of this opens up toward negative 3 sevenths? When I flip it around, the small end has to open up toward negative 3 sevenths. Notice here the large end of the inequality symbol opens up toward 11 sevenths. So when I flip it around, the large end has to open up toward 11 sevenths. And actually, now that I've switched that around, my smaller numbers here, larger numbers here, and these are less thans or less than or equal to's. So that's our perfect form. Now graph-wise, less than on negative 3 sevenths means parentheses. Less than on 11 sevenths means parentheses. And then we're always shading in between them for the three-sided compound inequalities. And let's take a look at an OR problem. We've got 4x is less than or greater than or equal to 9x plus 10. Or x is less than 3x minus 6. If you remember what I said, if you have two inequalities separated by an or, an or or and, you solve each one separately. So let's do the one on the left here. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on the left side, numbers on the right. So I take 9x over. And it becomes a negative 9x. On this one, well, actually, let me go ahead and finish this problem first. Combine together like terms. 4x minus 9x is negative 5x. Last step, divide both sides by the number in front of your x, which is a negative 5. When I divide by a negative number, I flip my inequality symbol. The greater than or equal to becomes a less than or equal to. So we get those negative 5s cancel away. So we got x is less than or equal to 10 divided by negative 5 is negative 2. Now we want to solve this one. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Third step, get everything with an x on the left side, numbers on the right. So I'll take 3x over to the left side. Take anything across your inequality symbol, the sign changes, so the 3x becomes negative. Combine together like terms at any step. 1x minus 3x is negative 2x. Last step, divide both sides by the number in front of your x, which is a negative 2. And when you divide both sides by a negative number, remember you flip your inequality symbol, so it becomes a greater than. So we got x is greater than negative 6 divided by negative 2 is 3. Now there's an or there, so this is an or between these. Well, let's graph this, and that may actually change what our answer looks like. Okay, so we got a -2, and we got a 3. X is less than or equal to -2. The equal to part means bracket. Less than means that shade to the left. The x is greater than 3. Greater than with no line underneath it means parentheses. And it's greater than, so we shade to the right. Now this actually doesn't change our answer any there, but if I wanted to write it in the interval notation, this is from -infinity to -2. Infinities always have parentheses, bracket on -2, bracket on -2. This is from 3 to positive infinity, because we're shading to the right. Infinities always have parentheses, parentheses on the 3, parentheses on the 3. And we put a union symbol in between them. And that's our last problem in that section. So let me go ahead and save it.